Let's keep this file for reference and call it a 2-stock portfolio. And then let's just copy that tab, hold down Control, and call this one a 3-stock portfolio. I'm going to add a couple of formulas so we can calculate the mean standard deviation of the 3-stock portfolio. And notice what's new is in our expected return of the portfolio, we've added the weight of the new stock and the expected return of the new stock. And in the standard deviation, we've added the weight times the standard deviation squared of the new stock, kind of goes along with the other two. And we've also added two terms, one for 2 times the correlation between the stocks times the weight of each stock and its standard deviation. And then we've done the same thing for another pair of stocks. So that if you look at that formula closely, you'll see each stock is being treated the same way. The more stocks we add to this portfolio, the longer and uglier that formula gets, and it grows exponentially with the number of stocks. So we'll stop at 3, but let's go ahead and work through 3. I'm going to insert a column to put that third stock's prices. I'll just insert a few cells here. And now we'll calculate the returns for the new stock. Check our math. Going to move the portfolio expected return and standard deviation out of the way. Line up the old stocks and add the new stock and bring it over. Now there are 2 complications we're introducing with this third stock. The first one's pretty straightforward. It's just a whole lot more terms in our calculations above. The other complication we're introducing is that we can no longer just choose the weight in one stock and then subtract from one to get the weight in the other stock. We pretty much have to find all 3 weights independently, and we want to put a check that they add up to 1. And let's just go ahead and make them all inputs. We might go 80, 10, 10, for example, 10%, and check that they do add up to 100. Now we need to replace these 2 formulas with these 2 formulas. Notice that the standard deviation formula requires 3 different correlations, basically every combination between any pair of these 3 stocks. So let's put them up here. And remember, with a correlation formula, it doesn't matter which array comes first. For the standard deviation formula, I'm just going to type it in and explain it as I go. We take the square root of each weight times the standard deviation squared. So weight times standard deviation squared. And then for each combination of correlations, we take 2 times the correlation times the weight and the standard deviation of each stock. So that term was for the Kellogg ExxonMobil combination. Next we'll do the Kellogg Walmart combination, 2 times that correlation times each weight times its standard deviation. And then finally the third combination, 2 times, we can't see it, so I'm going to click here and go down and over, times each weight and standard deviation. So now we've dreamt up a portfolio of these 3 stocks, and we've calculated the expected return and standard deviation for that combination. If we wanted to come over here and make a plot like this, we would have to come up with all kinds of different combinations of weights for our portfolio. It's not as straightforward as varying one to go from 0 to 100, and then the other one is 1 minus that. So what we need to do is dream up a few different combinations and then calculate our standard deviation and our expected return. So I'm going to turn off the sound and do that quickly. So I've dreamt up some combinations with no rhyme or reason, but each one sums to 100%. Now I'm going to move this standard deviation formula over here so we can copy it down, and the same with the expected return formula. I have the formulas in the right place, but they're looking at the weights over here that don't change. I want these 2 formulas to look at the weights in columns OP and Q so that I can copy them down. The easiest way to change all that is to select them both, Control H for search and replace, and anywhere I find E, column E17, I'd like to replace that with O3. So I've replaced them all. I should test them by putting these values in this first row and see if I get the same answer. And I do. I get 10.2 for a standard deviation and 5.8 for an expected return. So now when I copy them down, I'd better have some dollar signs in there. So anything that's in column E, F, G, or L, I want both the column and the row locked. Probably the column isn't necessary, but we'll go ahead and lock it. So let's select those 2 cells, Control H to replace. If you can find a column, find E, replace it with $E. And by doing them all, we now have formulas that we can copy down. Let's check that. Kind of lost the diversity in some of my weights here, so let's change that up a bit. Just to get some differences in there. Let's lose the data labels for now so that we can see better. And what we see is no longer a line. We see kind of a scatter of points. If we did enough combination, what we'd find out is that there's a whole cloud of points that's bound by a line called the envelope. of possible portfolios, the upper portion of that being the efficient frontier. So what we'd like to do now is find that envelope in the next video.